Hello dear friends, and welcome once more to this video today in our YouTube channel. In this video, friends, we shall be looking at those secret weapons that you should always use to score all of the marks as far as organic chemistry is concerned. So friends, watch the video from start to finish, because at the end of this video, friends, you shall be able to walk into that exam hall and score all those marks in organic chemistry. Friends, keep in mind that organic chemistry is that section in chemistry where most students always see it to be the most difficult, but guys, once you're done watching this video, you shall see it to be the easiest section in chemistry. So friends, just for a quick reminder, if you're new to this channel, friends, don't forget to hit that subscribe button so that you're going to be having all latest updates about all the contents we produce here. And friends, don't forget to press the notification icon to get notified each time we upload new videos. And friends, it took me quite a lot of time to present these contents for you, so friends, don't forget to give the video a like. Just press the like button beneath the video, friends. It's a plate that is your own gift to me. Let's get started, friends. Okay, great. So friends, as you can see, we have it on screen here. So friends, organic chemistry is considered to be one of the most difficult sections in chemistry where most students have difficulties with. But friends, I promise to break everything down into tiny bits such that you can go to that exam hall and score all the marks. So friends, let's start with the first point that is very, very important, guys. It's considered to be the most important point that once you know it, friends, organic chemistry becomes nothing for you. So friends, let's start with the first. I want you to start by mastering all your synthetic root, guys. Master all the synthetic root, guys. This point is so important. It deserves 4 stars. Okay, like I said initially, friends, the number of stars I put for a particular point tells you the importance of that point, right? Wait. So friends, know that organic chemistry can be summarized into what? Into synthetic roots. Okay, synthetic root is simply a summary of reactions that are under that most organic compounds undergo. Okay, it's a summary. So friends, after this video, guys, make sure you watch the one that is talking about the synthetic root for the most important reactions of benzene. Don't ever go to the exam hall, guys, without watching that particular video. It's very important. It's so risky for you to go to the exam hall without watching that video. You might just go to the exam hall and you meet only what you see on that video on paper. It's going to help you so much. Great. So friends, master your synthetic root, guys, because once you must have mastered synthetic root, there will be no question on organic chemistry that is going to be above you. Okay, no question. Great. So friends, you should also master distinguishing tests. Okay, master your distinguishing tests. You might be given so many organic compounds to distinguish, to devise methods and experiments that you can use to distinguish between those organic compounds. Okay, master them so well. And those important distinguishing tests I've highlighted, they include, guys, to distinguish between an alkene and an alkyne. It's so important, guys. You know, to distinguish between these two, guys, we simply need to use ammoniacal silver nitrate or ammoniacal copper chloride, right? Good. So that we expect to see a white precipitate. Good. That is for terminal alkynes. Okay, terminal alkynes, because these two compounds are going to give what are going to decolorize bromine water, right? So we don't use bromine water to distinguish between them, or bromine in tetrachloromethane. Good. So friends, you should also master that for an aldehyde and a ketone. This is very, very important, guys. Very, very important. Very important. And you know, guys, the main test in which we can actually, the main distinguishing test in which we can actually use to distinguish between these two guys, is to use the silver nitrate, right? The ammoniacal silver nitrate, because when we use ammoniacal silver nitrate with an aldehyde and we heat, guys, we are going to see what? Silver mirror, right? It's going to give us silver mirror with aldehydes, but not for ketones. There are some aldehydes, and at the same time, guys, you can still use the iodoform test, but you have to be careful, because there are, though ethanol is an aldehyde, right? Ethanol is an aldehyde, but you cannot use the iodoform test to distinguish between ethanol and a ketone, because they will both give you a positive iodoform test. Okay, it's going to give you a yellow solid, which is iodoform. Okay, so you have to be very careful. So the major test that you use, guys, is the ammoniacal silver nitrate, and you heat, where you see deposits of silver mirror. Good. Then friends, also an acid chloride and an acid amide. Okay, it's very important that with the acid amide and the acid chloride, all of these guys are simply derivatives of carboxylic acids. Good. So friends, you have to be very careful to distinguish between them. It's very important, because that for acid chloride guys, you can simply decide to hydrolyze, after which you treat it with silver nitrate. Okay, with silver nitrate, then you know that this acid chloride is going to release what? The chloride ions, right? And the chloride ions can simply give you a white precipitate with silver nitrate, of which the acid anhydride will not give you that. Great. So friends, you should also know how to distinguish between all the derivatives of carboxylic acid. Like I said, that the acid chloride, the acid anhydride, you also have the acid amides, you have the esters. All of them guys are the derivatives of carboxylic acids, and it's so important that you should know how to distinguish between all of them. It's super important guys. You can talk about things like carboxylic acid. To distinguish between carboxylic acids and alcohols, it becomes so difficult, but you should know that both of them are going to give you what? Are going to give you white steamy fumes when you react them with what? With PCl5, right? And otherwise misty fumes is due to the formation of what? HCl. Good. They will both give you the white steamy fumes, but to further distinguish between them, to tell the examiner which one is which, you need to use what guys? You need to use sodium carbonate, or use sodium hydrogen carbonate, such that with the carboxylic acid you're going to further see a colorless gas that turns lime water milky. Okay, and that gas is carbon dioxide, of which you can easily test it by simply bringing forth lime water beside the gas, and you see the milky nature it turns. Wait. So friends, I hope that was useful, and friends, don't forget to like the video. Please just press the like button, friends. That is your own gift to me. That is how you're also helping me as I'm helping you guys to pass your exam so well. Cool. And friends, don't forget to subscribe to the channel. If you've done so already, congratulations. Please do well to share that with your friends. If you've not done so guys, make sure you do it before you leave, because you're going to miss out on all interesting content that will produce here if you do not subscribe. Wait. So friends, and very important, when studying synthetic route guys, you pay attention to the reagents and reaction conditions. That is perfectly guys, that is super important, because guys, you know that reagents and reaction conditions in organic chemistry are very important. Okay, very important. Those are the basis behind the synthetic route, because if a synthetic route is being drawn like the one I'm going to draw after this video, the biggest thing that they can be asking you guys is the reagent and reaction conditions to lead from one compound to the other. It's super important guys, it's super important. Okay, so you have to pay attention to the reagents and the reaction conditions. Very important friends, very important. Like I said, there's going to be a video after this one, immediately after it, which is going to be addressing one of the most important reactions of benzene. So friends, make sure you watch that video. Make sure you watch it. You can only watch it guys once you subscribe to the channel. So friends, hit the subscribe button so that you have access to watch it. It's so risky for you to go to the exam hall without watching that video friends. It's going to be so risky, because you must see it there. You must see it. Experience has proven, okay, that you must always see those reactions in both paper 1, paper 2, and in paper 3 guys. It was in paper 3. Those who are so vigilant enough will notice that it came in paper 3. Good. Then friends, one of the most important guys, if you can study organic chemistry so well guys, then it shouldn't take you up to 30 minutes to finish. Okay, so once you must have studied all of what I've just told you guys, master synthetic routes, know this distinguishing test guys, to go to that exam hall guys, it shouldn't take you up to 30 minutes to finish. Okay, though the entire paper is designated for 3 hours, sorry, yeah, for 3 hours, but the organic chemistry section guys, once you study so well, it shouldn't take you up to 30 minutes. Great. So friends, let's move on to the next slide to see one of the most important things as well that you should take note. Wait, let's move on to it friends. Okay friends, let's also master the reactions of benzene, which include the following I'm going to list just now guys. Like I said, after this video you're going to have the one that is going to address that issue. Make sure you watch it guys, make sure you subscribe to the channel and watch it. Great. So guys, you're to master the reactions of benzene, which include, great, you have the Friedel-Crafts reaction guys. Okay, you have the Friedel-Crafts alkylation. That's very important friends, very important. You have the Friedel-Crafts alkylation, where an alkyl group is being added onto benzene. Great. Then friends, you also have the Friedel-Crafts acylation, where an alkyl group, guys, is being added onto benzene. Right? Then you also have the nitration of benzene, where a nitro group or the nitronium ion is being added onto benzene. Okay, great. Then friends, we also need to know the sulfonation of benzene. This is very important, friends. These reactions are very important about benzene, very important. Then friends, you should also know how to distinguish between the primary, secondary, and tertiary alcohols. It's very important, guys. You know that to distinguish between this primary, secondary, and tertiary, all we need is Lucas reagent, right? We need Lucas reagent, and you're going to observe so many changes. Okay, so many changes. Like some of them will form cloudiness after a certain amount of time, others will not form. Great. So friends, master them. If along the video, guys, and you discover that you cannot get an answer to all of what I'm saying, guys, just put in the comment section down below and I'm going to attend to you. Keep in mind that, guys, your success is my priority. Great. If after making all these videos and you do not pass, guys, I won't be happy. Okay, I will not be happy. That's why I'm doing everything possible to make sure that all my students, all those watching me, all my audience have the best of which they can think of. Great. So friends, should also know how each of the derivatives of carboxylic acids can be gotten from a carboxylic acid. Grade. Like for instance, guys, you should know, like for instance, if I want to convert from a carboxylic acid to what, an acid chloride, right? I simply need I can use PCl5, right? I can use that's SOCl2, right? Great. And to convert from a carboxylic acid to, let's say, an acid anhydride, let's say an acid amide, I need ammonia, right? Great. I also need other reactions. So friends, it's super important to know how to convert from each of the derivatives of carboxylic acid. That's to convert from a carboxylic acid to each of its derivatives. Like to leave from the carboxylic acid to arrive at an ester, I simply need what? A suitable alcohol, right? Through an esterification reaction, of which I'm using sulfuric acid as my dehydrating agent. Great. Okay, yes, it's super important, friends. Super important. And friends, after this video, like I said, don't forget to watch the one that is going to be addressing the most reactions of benzene amines, because it's super important. It's super important, guys. Make sure you watch the video after this. Then friends, let's move on to the next slide to see. Wait. Okay, friends, never forget to identify these compounds I'm about to list just now. Okay, don't ever forget to how to identify these compounds I'm about to list now. The first compound, guys, we have carbon. Know how to identify carbon. Okay, no, it's super important, very important, friends, how to identify carbon, because organic compounds are going to be given and you shall be asked to devise methods on how you can identify each compound. Carbon is one, guys. Then the next you have hydrogen. The other, guys, you have chlorine. Oh guys, super important. Chlorine, super important. Then you have nitrogen, super important, guys, and you have sulfur. Great. So guys, these are the compounds that that you might be asked to devise methods on how you can distinguish them. Never forget them, guys. Okay, never forget them. They are super important, very important. You cannot enter into any GC hall or any jam or any exam hall in organic chemistry, those taking the advanced level, without them asking you. Okay, it's very important. Great. Then friends, should never waste your time, guys, trying to balance an equation in organic chemistry. Okay, you should never waste your time trying to balance an equation in organic chemistry unless you are to use that equation to do some calculations. Keep in mind that to balance equations are very important once you're working with physical and inorganic chemistry. Okay, once it's organic, don't waste your time trying to balance. Once you're able to identify the most important and desired product, guys, you're good to go. Okay, don't waste your time to balance equation unless the equation has to do with calculations, or better still, they can be asking you to calculate the percentage yield of a certain when a certain compound is being produced in an industry also. Okay, when you at that point now you need to write a balanced equation to see how to see the number of moles, okay, to see the mole ratio, to see how the ratio of the reactants that you're using, okay. Yes, so it's also going to help you to determine which of the reactants is the limiting reagent and which one is the excess reagent. It's super important, friends. Don't forget this point, because most of the time students go and waste their time trying to balance equations in organic chemistry. Don't, guys, don't balance unless you have to use it to do calculations. Great. And friends, you should also learn reactions of different functional groups, okay. Learn them. Like for instance, to convert from an alkene to an alkene, I know I have to do hydrogenation, right? Hydrogenation, and I need a catalyst. That's I need mostly the transition metals. Yes, I can use platinum, I can use palladium, okay. Yes, also know how to convert them. It's super important, guys, very important. Then as well, for instance, to leave from an alcohol and arrive at maybe a carboxylic acid, I know that I have to do oxidation. And if I am to leave from an alcohol to a carboxylic acid straight, I can either do it in two ways, okay. I can either use just potassium permanganate or the permanganate ion. It is going to leave from the alcohol and arrive at the carboxylic acid straight. But if I want to use potassium dichromate, if I don't heat, guys, if I just use mild oxidation, or if I just use potassium dichromate, right, only potassium dichromate, I'm going to leave from an alcohol and I arrive at an aldehyde. Before leaving from the aldehyde, now I'm going to the carboxylic acid, which is going to be time constrained and time taking. But if I still want to use only the potassium if I still want to use only the potassium dichromate or the dichromate ion and leave from the alcohol straight to carboxylic acid, in this case now I need a method in which I can speed up the rate of the reaction, and by so doing I must heat, okay. I can use potassium dichromate and heat up the reaction to make it faster, such that it's going to leave from the alcohol and arrive at the carboxylic acid. Great, very important, guys. And like I said initially, that reagents and reaction conditions are super important. Like for instance, if I want to leave from maybe a halogenal alkane and arrive at an alkene, right? In this case, I'm going to use potassium hydroxide and I'm going to use alcoholic solution. Great, I'll use alcoholic solution. It is going to leave from a halogenal alkane and arrive at what, guys? At an alkene. But take a case where I still use a halogenal alkane, and this time around I want to leave now from the halogenal alkane now, and I arrive at an alcohol. In that case, guys, I will still use potassium hydroxide, but in this case now not an alcoholic solution, but now, guys, what, an aqueous solution. And the condition is that I have to reflux that guy, okay. I have to reflux it. Great. So friends, you should also know how to define terms, important terms like hybridization, hybrid orbitals, homologous series, functional group. You have isomerism, you have chemical shift, you have chiral center or chiral carbon atom. Yes, guys, so these are the most important terms you know how to define. Other terms can include inductive effects, resonant effect, mesmeric effect, and so on and so forth, guys. So make sure you know those definitions, guys. They are super important. So guys, finally, you should also know how to identify various isomers of different compounds. You should take special note, guys, on optical and geometric isomerism. Keep in mind that for a compound to exhibit optical isomerism, it must have a chiral center or a chiral carbon atom, a carbon atom in which you cannot draw any line of symmetry through it, a carbon atom in which it is linked by 4 different groups, okay, 4 different groups. I didn't say 4 different functional groups, guys. I said 4 different groups. If you said 4 different functional groups, guys, you're going to have some shortcomings, okay. It is not going to be perfectly correct. It won't be perfectly correct because you can have a carbonium ion which is linked by, you can have 2 different functional groups, but you can also have other 2 groups that you might have a methyl group and an ethyl group. Okay, those are two different groups but not two different functional groups, so take note guys, take note. So friends, thank you very much for watching the video. Thank you so much for watching the video. At least you've told me that I've actually done something that can help you. Great. So friends, I look forward to see all of you in that video I said is going to come up after this video. Make sure you watch it guys, and if you've not subscribed to the channel guys, make sure you hit the subscribe button so that you'll be able to watch that video. And guys, it took me quite a lot of time to prepare this content for you friends. The only way I'm asking that you should support me guys is just by clicking on the like button. That's all guys, that's all I want you to do, and put in the comment section if the video was useful for you. If it was not useful guys, and I'm going to improve on how I can make it move well. Thank you guys, and have a blessed day.